Welcome. Have you ever stopped and wondered how a piece of software actually makes a choice? How it decides between yes and no, or this and that? Well, today, we're going to pull back the curtain and see exactly how code thinks. We're going to build a simple C++ program right from scratch. So let's dive in. So let's start with the big question. How in the world does a computer make a decision? I promise you, it's not some kind of mysterious magic. It's actually something way simpler and, honestly, a lot more powerful. It's all about pure, structured logic. And we're about to see how we can put that logic to work. And to really get it, we're not just going to talk about theory. Nope. The best way to understand coding is to actually do it. So we're going to get our hands dirty and build something practical. A small but super useful program that shows us decision-making in action, one step at a time. So, what's our project? A simple grading program. Just imagine a school that needs a tool to automatically assign letter grades based on a student's score. That's our mission today, to write a program that can take a number and spit out the correct grade. Simple as that. Okay, so this is our rulebook. It's the entire goal for our program. If a student gets a score under 25, that's an F. If they get between 80 and 100, that's an A. Our code has to learn these rules and apply them perfectly, every single time. Now, before we can write our logic, every single C+ program needs a foundation. You can think of it like a code skeleton. It's kind of like setting up a clean kitchen. You get your main mixing bowl out before you even start looking at the recipe. The official term for this is boilerplate. Now, that might sound a little technical, but don't worry. It just means the standard, essential starting code that you'll use for pretty much every program you write. It just saves you from typing the same basic stuff over and over again. And this is it. This is our boilerplate. That first include line is basically telling our program, hey, go grab a toolbox full of useful stuff we might need. And that int main part, that's the starting line. It's the main stage where all the action is going to happen. Every C++ program kicks off right there. All right, our kitchen is all set up, so what's the first step in our recipe? We need our ingredients. Before our program can assign a grade, it has to know the student's score. That means we need to ask the user for it and have a place to put it. And to hold that score, we use something called a variable. It's really nothing more than a labeled box in your code where you can keep a piece of information. In our case, we'll make a box, label it marks, and that's where we'll store the student's score. And getting that input is a simple two-step dance. First, we create the box. We write int marks, which just tells the computer, hey, I need a spot to store a whole number. Second, we fill that box with sin squiggle marks. That tells the program to wait for the user to type something and then bam, put it right into our marks variable. Okay, we've got our ingredient. The score is safe and sound in our variable. Now we get to the heart of it all. This is the recipe itself. This is where our program actually thinks and uses logic to make a decision. So we have to take those rules from our grading table and translate them into a language that the computer can actually follow. And that language, at its core, is just clear, unambiguous logic. And check out how direct that translation is. In English, we think, if the marks are less than 25. And in C++, we literally write, if marks less than 25. It's almost a perfect one-to-one match of how our brain thinks. See? You're already thinking like a coder. So here is the whole logic block. The program is like a bouncer at a club. It checks the first if statement. Let's say the score is 72. It asks, is it less than 25? Nope. Okay, is it less than 45? Nope. It just keeps going down the line until it finds a condition that's true. Ah, is it less than 80? Yes. It assigns a B, and then its job is done. And here's why using else if is so smart. As soon as the code finds the right answer, as soon as one of those conditions is true, it runs that piece of code and then completely skips the rest. It doesn't waste time checking things it doesn't need to. Now, for one student, that's no big deal, but imagine grading thousands, that efficiency becomes a huge deal. So the program got the input, it thought through the logic, it made its decision. What's the last step? We have to tell the user what the result is. It's time to serve the dish and show them the final grade. And to do that, inside each of those if and else if blocks, we just add a simple command, cout. It's short for character output, and it just tells the program to print something to the screen. So if the marks less than 25 condition is true, it'll just print out a big F. Easy peasy. And there you have it, the finished product. You can see how all the pieces we just talked about fit together like a perfect puzzle. We've got our boilerplate foundation, the variable to get the input, the if-else-if logic to do the thinking, and the cout statements to show the output. It all just works together. So we did it. We successfully built a program that can actually think logically. But, this is really just the beginning. Real-world programming is all about taking these basic building blocks and using them to solve much, much bigger problems. I mean, think about it. Our program works perfectly, for one student at a time. But what if you needed to grade a whole class of 30 kids, or an entire school with thousands of students? How would you make this simple idea scale up? Well, that's where you'd start using more advanced tools. You'd wrap our grading logic up in a neat little package called a function so you could reuse it easily. You'd use loops to make the program run that function for every single student automatically. And you'd use arrays to keep all those student scores in one organized list. So we went from a simple question to a working program that can grade one student. But the real magic, the real power of coding, is scale. So the question I'll leave you with is this. What would it take to make this program grade 1 million students? The answer to that? Well, that's the next step on your coding journey.